Hello, my name is Mumcuoğlu. I'm an electrical and electronics engineering student in Bilkent University, and today I'm going to tell you my Physics 102 lab project. My project is the examination and experimentation on the capacitance values of the aluminum-covered homemade plates, and the experimentation will be about their capacitance values with different area plates and different dielectric materials between them. So, in my project, I'm going to be using 6 plates, two of them, which is 13 centimeters times 15 centimeter wide. The other is 17 centimeter times 18 centimeter wide, and last one is 23 centimeters times 25 centimeters wide. So these plates will be 0.04 meters distance between them, and I will put 3 different dielectric materials between these plates and examine their capacitance values. The first dielectric material will be just a dry air, the second will be nylon, and the third will be polystyrene. And the electric constant of dry air is 1.00059. The dielectric constant of nylon is 3.4, and the dielectric constant of polystyrene is 2.56. And I will be using a multimeter to calculate the capacitance between my plates. I will calculate the distance between plates with a ruler. I will use aluminum covered boards as capacitor plates. And I will give a slightly bit of power to my plates in order to calculate the capacitance.
The initial capacitance value of the capacitor will be equal to the permittivity constant of free space times area of the place over the distance between the plates.
This is the capacitance formula I'm going to be using. It means that the final capacitance of the place is equal to the initial capacitance of the place times the dielectric constant between the place. Also, Q indicates the charge on the place. V indicates the potential difference between the place, but Q and V will not be used throughout the experiment. This is the percentage error formula I'm going to be using to calculate the percentage error of the slopes of the baselines of capacitance value plate area graphs of the electric mediums. And this is the average formula I'm going to be using. I will use it to calculate the average percentage error of the percentage errors I calculated, which means that the average percentage error of the whole experiment. And this is the materials I'm going to be using.
So as you can see, this is my experimental setup on my table. As it can be seen from this video, I am calculating the capacitance values of the homemade aluminum foil covered boards acting as capacitors. I did my capacitance calculations on 3 different sized capacitors with the electric mediums, which are dry air, nylon and polystyrene, between all of them separately using a multimeter. Additionally, the distance between these plates is 0.04 meters. These are the capacitance values of theoretical and experimental parts for different dielectric mediums. These are the capacitance plate error graphs of theoretical and experimental scenarios of different materials. This is the slope values of each of these graphs. This is the error percentages of each of the medium. Dry air and polystyrene are negative, meaning that the experimental capacitance values were generally higher than the theoretical ones, and the positive nylon means that theoretical capacitance values were overall higher. And this is the overall average error percentage of the whole experiment. It's negative, meaning that general experimental capacitance values were higher than theoretical values. The overall general higher values of experimental capacitance values over theoretical values is presumed to be caused by personal errors such as instability of the hands during the calculations, the inaccuracy of the calculation equipment,